Hello everyone. This is Prachi this side, and I have my team members Manav, Saloni, and Shivani with me. We are presenting our project on the SYN flood attack using Hping3. This was conducted in a virtual lab to simulate a real-world uh, DOS scenario and analyze system response and logs. Each of us worked on different parts of the attack detection and mitigation process. Next slide, please. A SYN flood is a type of DOS attack that takes advantage of the TCP handshake process. By sending a large number of SYN requests without completing the handshake, the attacker exhausts system resources. Our objective was to simulate this attack using Hping3, then analyze if and how the system responded. Next slide, please. Now we set up a virtual lab using the subnet IP 192.168.16.0/25. The attacker VM was Kali Linux with IP 192.168.16.17. The target was a web server on 192.168.16.4. There was another VM, and the IP was 192.168.16.5. This IPs was used to inspect logs and monitor the network. All the VMs were on the same virtual network, allowing the full visibility of the traffic. Next slide, please. Now, the Hping is a powerful packet crafting tool often used for testing firewalls and networks. We use it to flood the target with SON packets. Our command sent a continuous stream of SYNs to port 80 to simulate a denial of service scenario. Now, the next slide, Manav will show the attack diagram and live attacks.
Thank you, Rashi. This is the attack diagram which we simulate in the scenario. So, as Prachi mentioned, the attacker has first of all the subnet is 192.168.16.0, and in that we uh, join attacker 192.168.16.17. We perform attack using hping, and this is the server firewall of wavehost server. The server's IP is 192.16. uh, the logs, uh, sending the logs, and we are using nmhost to monitor logs in log analyzer and top ng. We connect nmhost sorry, we connect web host using SSH, and we use netstat TCP dump. Uh, and before moving forward to live attack, I will want to add that how the TCP handshake work. So in the TCP handshake, the client sends the synchronized SYN messages, and the server reply with the SYN with the acknowledgement message. The client responds with the acknowledge message. Let's move to how we execute our attack. So this is the uh, image of Kali Linux, uh, where terminal image of terminal, and let's do it live. So I have started all the VMs. So as in IP config, we can see that it's IP address. and we use uh, we add Kali uh, using yeah custom VNet too. So we created a specific virtual network for this attack. Now let's start the attack. Yeah, so as this is the command to do this. Yeah, so now the attack is started. Let's see in the NM host how attack will affect the web host. Just a second. As you can see, the it take time, but the web host service is on. Uh, because of the attack is it's take time because attack is on, but the web host system is on, and we can see. Let's find out what's happening in the end of ng. So in the dashboard, we can see that the one dangerous flow is showing up. It's probably the attack we started. So let's see what's happening over there. As you can see, the protocol is at TCP and connecting. This is the detail. Yeah, let's see in the web host. Yeah, as you can see, the log analyzer showing the warning, and the firewall is working perfectly. That stopped the UFW, stopping the synchronized package at SNY flood attack. So as you can see, the source is 192.168.17. Then the destination is web host. And now let's check all. Uh, this is the flow. Yeah, yeah. So how this will be working, that you can see. Uh, PF sense is purging the flow, and now we check in this web host all the logs of firewall as well as the system logs, and we use and TCP dump. As you can see, uh, packages, yeah, all the traffic in the TCP. So package is acknowledging, and we can see lots of win. So this is show how the attack is happening, and now we check with the nested. Oh, I have to wait, restart the. Yeah, you can see many open, half open ports. uh let's do this thing. This command used for the socket, which was used in web host. So it will check the status of the sockets. Yeah, all the sockets are perfect, and uh, because of the firewall that's stopping the attack. Let's check the firewall logs and as well as the system log. So to check that, we use sudo tail /etc/logs. So let's stop the attack make make it fast. Yeah, this is the command for um, checking the logs of firewall. As you can see on the log analyzer as well as in the log, the UFW is blocking the all the packages, and this is the source which the attacker is trying to send the packages, and this is the destination of the web host IP address. Now check for the system log as well as. Yeah, as you can see on the system log, it will showing the same thing. Uh, Now we will. This is the all the observation we do. Now we will go back to the PP presentation. Uh, so as I did this attack before, and I take this snapshot uh, before this attack. So purging this is the image that show the purging the flow. This is the host, and this is the showing the alert. And as you can see over here, there is a sudden spike of the web host that getting more and more packages. Uh, this is the TCP dump image. Uh, I take it, and as you can see in the image, the this all the SSA traffic indicate high interactivity, or uh, it's it's showing that it's automated traffic and scripted traffic. The next observation will be explained by Saloni.
We then use the sudo netstate -ant command to analyze network connection in real time. During the attack, we noticed a significant number of hub open TCP connection in the SYN receive state. This is typical in SYN flood attacks and serves as a strong evidence that an attempted denial of service was in progress. Next slide, please. We first reviewed the UFW firewall logs directly from the terminal and observed that the logs confirmed exactly what the log analyzer reported. UFW was actively blocking incoming SYN packets from the attacker. This shows that while the SYN flood attacks was ongoing, the firewall successfully intercepted the malicious traffic before it could reach the application layer. As a result, the targeted application remained stable and continued to run without disruption. Next slide. We used several tools to collect evidence. TCP-DUM showed a constant flow of SYN packets to the server. UFW.log confirmed that the firewall was actively dropping them. Netstate showed no abnormal half-open connections. NTOPNG revealed traffic spike from the attacker, and all these tools provided conclave evidence of the attempted attack. Now I will hand over to Shivani.
Hello. Next slide, please. Yeah. The attack was detected immediately by UFW, which logged the connection attempts. TCP dump and top NG also supported the detection. The firewall acted as the first line of defense. Since the packets were dropped at the network level, the attack never reached the application layer. This highlights the importance of network layer protections. Next slide. We can implement it. We implemented multiple prevention methods. This included UFW rate limiting and tables rules to restrict SYN floods. We also enabled SYN cookies at the kernel level, monitoring tools like NTOPNG and TCP-dump allow for real-time alerting. For more advanced detection tools, tools like SNOR or Suricata can be used. Overall, a layered security approach helps block and monitor attack effectively. Next slide. In conclusion, our project successfully simulated a SYN flood using Hping3. We captured evidence with tools like TCP dump and TopNG and UFW logs. The firewall blocked the attack before any damage occurred. This experiment proved the effectiveness of basic firewall configuration and the value of continuous monitoring. Next slide. Thank you all for your time and attention. That concludes our presentation of the SYN flood attack using HPing 3. Thank you.